So we're going to get started with section 6 today. We're going to spend a couple days on section 6, just like we did with section 5. And we're going to talk about radical expressions and then rational exponents. Radical, remember, is anything that has a root symbol in it. So like most commonly, you guys have seen square roots, but we also have like cube roots and fourth roots and fifth roots and all of that. So we're going to be working with those and figuring out how do we simplify, which at the very, very beginning of the school year, which I know was a while ago, we did talk about like simplifying square roots, where you guys were finding perfect square numbers that went into the number that they were giving you, and then you broke it down. So like you simplified it. They call that like rationalizing the radical. So what we did is we would look for those perfect square numbers. So just to kind of refresh what those are: 4, 9, 16, 25, 36, and so on. And I think I went up to like 144 maybe. And, you know, those are like, that's 2 squared all the way to 12 squared. And so if they gave you a number that wasn't on this list, so they gave us a 42, or they gave us a 38, something like that, what we did then is we looked from our list of numbers here, which one could go into it, if any. And we always tried to find the biggest one. And then we broke that number that was underneath the square root sign down using one of these perfect squares. And then we square rooted that number. And so sometimes you would have a whole number sitting out front of the radical, and you might have a piece still left underneath it. So we're going to work a little bit more with that today. And then in the future with this section, we're also going to talk about rational exponents, which is when you take something that's underneath a radical sign and you rewrite it so that it's a number or a letter with an exponent. But the deal with the square root signs and my cube root signs is that when you write the number with an exponent, it creates a fraction for the exponent. So you're going to have like x raised to the 1/2 power or something like that. So we'll get to that probably towards more like the middle to the end of this section. We're going to spend more time today just working on simplifying these radical signs. So just remember that 5 squared is 25, and -5 squared is also 25. You can square the positive number, and you can square a negative number and still get a positive outcome, because you have 2 even, or you have 2 negatives or 2 positives, and that always causes the answer to be positive. So when we square root something, there's always a positive and negative side of things. Most of the time, we focus on the positive, like the square root of 25, most people would say 5. Or the square root of 36, people would say 6. Because that's like the principal square root that we think about. What's the one that you see or hear most commonly? Okay, now we also have other roots. We don't just have square roots. We have, like I said, cube roots or fourth roots or fifth roots. Those are all called nth roots. So I could take the 3rd root, the 4th root. I could take the 10th root, the 20th root of a number if I really, really wanted to. And how that's going to get written is it's going to look like this. You're still going to have a square root sign, but you might have a different number kind of in the corner of that square root sign. If it's a regular square root sign like this, normally you don't see a number written in the corner. There is technically a 2 sitting here. If it's a square root sign, though, we don't usually put a 2, just like we don't put 1s in front of all of our plain x's. Okay, but in the future, you're going to start seeing something like this, like a cube root, 4th root, 5th root, and so on. They're going to start throwing those other numbers in there. But just know if you don't see a number, it's just the plain square root. There is technically a 2 in that corner. So when a number has more than one root, the radical sign indicates only the principal or the positive square root, like we talked about. If I square root 25, I think 5. I don't always think positive and -5. So for these ones today, I'm not expecting you guys to be putting plus minus signs in front of all of your answers. We're going to focus on the principal root. We've already dealt with the plus minus sign like when we were solving quadratics, so we know that it's there. For these problems, we're just going to be focusing on the positive side of things, unless there's a negative on the outside of the square root sign, or when we start getting to these other roots, sometimes your answer will come out negative, because you may have an odd number of negatives in a problem. All right, let's get into some examples here. First one says the square root of 8. Now, if I think about that list that I had up on the top here, 8 is not on this list. 4 and 9 are, but 9's too big. So what I would have done in the past is I would have rewritten this as 4 times 2. And the reason why I'm rewriting it is because 8's not a perfect square number, but 4 is, and 4 can go into 8. And what would be the square root of 4? 2. So this 4 becomes a 2, and then we have to put it out front of the square root sign. So it becomes 2 square root of 2. Now, if we look at number 2, it's a little bit different because it's got a 3 up next to that square root sign. So I'm trying to find the cubed root of 8. Does anyone happen to know what that would be? 2. Okay? 2 times itself 3 times gets me 8. 2 times 2 times 2. Now, when you start getting to numbers that you maybe don't know off the top of your head like that, because 8's a fairly small number that I could have just kind of thought about that to myself, your calculator can do these things. When you guys have your calculator out in front of you, you're going to want to look for the key that says this. It has like an X next to the square root sign. And if I wanted to type this into my calculator, you need to put a 3 in first, and then the square root sign. It's usually right above where your square root sign is at, and it has like an X next to the square root sign there. And that just means like you could put in any number that you wanted for the square root. So I would type in a 3 first, and then hit that key, and then put in an 8, and then hit enter, and your calculator should say 2. Okay? Now how about number 3? 3 looks just like number 2, except it says -8 underneath that root sign. So what number times itself 3 times would get me a -8? Good, -2. Do you guys remember when we talked about imaginary numbers, i's? And that came up when we had like the square root of a negative number. And I said, if you type in like the square root of -16, your calculator's not going to do it for you. It's going to give you an error message. That's because I can't take a negative number times itself twice and get a negative number. It's always going to be positive. But for cube roots, so like a root that's odd, so like a 3, a 5, a 7, a 9, I can take a number times itself an odd number of times and get a positive or negative answer. So this one I was able to do because the root has changed. It's not the square root anymore. Okay, let's talk about what do we do when they give us letters. Okay, for these next couple, I don't have any number that I'm actually having underneath the square root. It's like x with an exponent or y with an exponent. Remember how I told you guys that all of these regular square root signs have like a little tiny 2 in the corner? When you're square rooting a letter with an exponent, when it's a 2 or a 3 or whatever, you want to try to take that exponent and divide by whatever number's next to that square root sign to then get your new exponent. So this one, if I take 8 divided by 2, this becomes x to the 4th power. So what would number 5 become? Good, y to the 5th power. Now when I look at 6, 3, I can't divide that nicely by 2. I would get a decimal. So remember, x to the 3rd means that you have 3 x's. You have x times x times x. So what I'm going to do to help me out is split my x to the 3rd apart. I'm going to take one of my x's away, and so I'm going to write it as x squared times x. Okay, and the reason why I'm doing this is so that I can simplify that x squared, and that x that I pulled off is going to have to stay underneath the square root sign. So when I do this, x squared, it's like 2 divided by 2 from the square root sign. That just becomes an x. Okay, so this becomes an x and it moves out front. Now the other x that I pulled off of x to the 3rd has to stay underneath the square root sign. So it looks like that, x square root of x. Now you can do that for any number. So if you had y to the 11th power, take off a y and have y to the 10th and then your y. And then you can simplify your y to the 10th by dividing that by 2. The same thing happens in, like, let's say all of these had a little 3 in the corner instead. You want to get your exponent to a number that's divisible by 3. So for x to the 8th, if that was a 3 instead, I would take 2 x's off. So I would rewrite it as x to the 6th power and then x squared, because I can take 6 divided by 3. So whatever your number is that's by your root, that's what you want your exponent to be based off of. Like, what do I need to change it to so it's divisible by that number? And you can always take off as many as you need to get to that point. If we look at the last one on this front page here, we have x to the 5th, y to the 6th. This is a regular square root, which means I need to get these numbers so that they're divisible by 2. Is 5 divisible by 2? No. So what should I do to my x? Take 1 off. So I'm going to rewrite it as x to the 4th times x. Now for my y, is 6 divisible by 2? Yeah, so I don't need to change anything about the y. So I'm going to go ahead and just leave that at y to the 6th power. So x to the 4th would become what? Good, x to the 2nd. That takes care of that one. Now this x is going to have to stay. I can't do anything with it. Let's go ahead and take care of the y. What's 6 divided by 2? 3. So I have x squared, y to the 3rd. Those both come out front. And underneath my square root sign, I need to write x. All right, let's turn the page over. All right, so what we're going to see for the majority of these next problems is we're going to start combining the things that we just talked about. These are going to have numbers and letters, and they're going to start also changing the root sign. Okay, so instead of a square root, you're going to start seeing the cube root show up more. Okay, so let's take a look at number 8 together. We have the square root of 18 and an x. Now, 18 is not a perfect square number. It wasn't on that list of numbers that I wrote on the top of my screen at the start of class. So, thinking about those numbers, the 4, the 9, the 16, 25 is too big. So out of 4, 9, and 16, which one of those numbers can go into 18? Good, 9 can. So I'm going to rewrite 18 as 9 times 2. The x, can't really do anything with it. It's just an x all by itself. So I can't take an x off to get it to be divisible by 2. So I may not be able to do anything with that letter. I'm just going to have to leave it alone. Now the last thing to do here is square root the 9. So that becomes a 3, and that goes to the front. The 2 and the x, again, there's not a lot we can do with those, so they have to stay underneath the square root sign. So we have 3, and then the square root of 2x. All right, why don't you guys try on your own numbers 9 and 10. All right, for number 9, 200 is not a perfect square. Which perfect square number can go into 200 though? 100. So 100 times 2. Now for those letters, x and y, you want to make sure that the exponents are a number that's divisible by 2. Now 4 is, so I don't need to do anything to my x. But for my y, I needed to split one off. So it becomes y to the 8th times y. Okay, so now let's simplify. The square root of 100 becomes 10. That takes care of that. I'm not going to be able to do anything with 2, so I'm going to leave that alone. I'm going to skip over now to x to the 4th. What does x to the 4th become? Squared. What does y to the 8th become? Good, to the 4th. And then what's left underneath the square root sign is a 2 and a y, and I can't do anything with those, so I had to leave them. 2y. Okay, let's take a look at number 10. Anyone know what perfect square number goes into 192? Good, 64 times 3 is how I can rewrite 192. Now, I'm sure there's other ones, like 4 might even go into that. Remember, you always want to pick the biggest perfect square. So you want to try to test some of those bigger numbers too, because if you don't do that, you're going to have to reduce again until you get it all the way down. Okay, I don't have to do anything to a to the 4th or to the b squared, because 4 and 2 are both divisible by 2. Now c has to become c to the 10th times c, because 11 is not divisible by 2, so I got to break one off. What's the square root of 64? 8. 3 is going to have to stay, so I'm going to skip now to my letters. So it's going to become a squared, b, c to the 5th, and then underneath the square root, there's a 3 and a c left. And that takes care of all the items. All right, so moving on to the next couple here. We're starting to see 3's show up in our roots instead of just a square root sign. Okay, we handle this the same way. We try to figure out if we can cube root the numbers or the exponents. Now the exponents, you're going to want them to be a number that's divisible by 3 for these ones. On those last couple, I wanted them all to be divisible by 2. So what I would do first is I would grab a calculator and I would test and see if I can find the cube root of 81. So you're going to do that 3 and then put that button that has a little x next to the square root sign and an 81. And when I do that, I get 4.32674871. So that means that 81 is not a perfect cube number. Like I can't cube root it and get a whole number. So what I'm going to need to do instead is try to break 81 down to a number that is able to have a perfect cube. Now you can think of this the same way you thought of those square root signs. Like perfect cube numbers, think like 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd I think is 64. These ones I don't know as well because they're not used as often. But you could do the same, like make another list for perfect cubes and then start testing some of those numbers. Now I know, like I was listing off, 3 to the third is 27. If I take 81 divided by 27, I get 3. So I'm going to rewrite 81 as 27 times 3. Now, 8 is not divisible by 3. What number smaller than 8 would be divisible by 3? 6. So I need to take off 2 A's to get down to a to the 6 so that I can divide that one by 3. All right, so to finish this off, the cube root of 27 is 3. That takes care of the 27. I'm not going to be able to do the cube root of 3, and I can't break 3 down any more than it already is. A to the 6th power, I'm going to take 6 divided by 3, which is 2, so it's a squared. That takes care of that one. And then I'm left with that a squared underneath the square root sign, and again, I can't do anything more at this point, so that 3 and that a squared are going to have to stay underneath the cube root sign. All right, let's go ahead and look at 12 together, and then I'll let you guys try number 13. Okay, so again, I would start by testing 320. So take the cube root of that, and I get 6.8399, and it keeps going. So that's not a perfect cube number. So I am going to have to try to break this one apart as well. So for 320 here, I would start dividing by your list of perfect cube numbers. Like I said, you think to yourself, like 2 to the third is 8, 3 to the third is 27. And if you have to do some of that first before you divide, you can use your calculator to do that too. Like, I don't expect you guys to have all of that stuff memorized. It's going to take some time to get used to that. The one that I know goes into it is 64. Okay, so I'm going to rewrite negative 320 as negative 64 times 5. Now, x to the 6 is 6 divisible by 3. Yes, because I would get a 2. So I don't need to do anything to my x to the 6. I can go ahead and just leave that as is. All right, can you guys tell me what the cube root of negative 64 would be? That would be square root. Negative 4, okay? Because negative 4 to the third power would be negative 64. I can't do anything with that 5, so let's move on to x to the 6. You guys told me that 6 was divisible by 3 because I would get what? What's 6 divided by 3? Okay, so that takes care of that, and then that 5 has to stay underneath the cube root sign. So negative 4x squared cube root of 5. Okay, you guys go ahead and try 13. All right, so 512 is a perfect cube number, so I don't need to do anything to that. But I do need to manipulate my letters a little bit because I need them to be with exponents that are divisible by 3. So a to the fourth and c to the fourth, we're going to do the same thing with them because both of them have 4s and I can't divide 4 by 3. So I'm going to rewrite both of those like a to the third times a. And that b that's in the middle, there's nothing I can do with that either. And then I'm going to rewrite c to the fourth as c to the third times c. Now, when I cube root 512, this becomes 8. 8 times itself 3 times is 512. Now, when I go to move this out front, there's already that 8 sitting out front, right? So what I need to do is actually multiply those two numbers. So what's 8 times 8? 64. Then my a to the third is going to become an a, and so is my c to the third. Everything else, so the a, the b, and the c, they all have to stay underneath the cube root sign. All right, we've got a couple more on this page. They're starting to throw in some other roots here. So for 14, we've got the fourth root. So 48, you would type this in the same way that you were typing in your third roots, except you would use a 4 instead of a 3. Now 48, I cannot take the fourth root of that. I'm going to get a decimal. So again, I'm going to have to start thinking of fourth roots. So this would be numbers raised to the fourth power, and trying to find one that goes into 48. So 2 to the fourth power is 16. If I take 48 divided by 16, I get 3. So, and 3 is a small enough number that I'm probably not going to be able to do anything with it. So that's probably the combination that I want. I want 16 times 3. All right, now with our letters, remember we want exponents that are divisible by the number by the square root sign. So this one has a 4. X to the fourth. 4 is divisible by 4, so I don't need to do anything to my x. Now think about y to the 7th. We're going to have to split this one. Right now I'm at a 7. I need to get down to a number that's divisible by 4. So how many y's do I need to take away before that happens? 3, because I need a y to the fourth and then y to the third. Okay, so the square root of, the fourth root of 16 is going to be 2. Can't do anything with the 3, so I'm jumping over here to my letters now. X and y are both going to do the same thing because they both have 4's as their exponents. So it's just going to become x and a y. And then the 3 and the y to the third have to stay underneath that fourth root. Okay, I'll let you guys try 15. right, so let's take a look at 15 here. Again, I would always just test first, is the number that's underneath the root sign able to be done? Like, can I do the 5th root of 32? I would always start with that first. And if it can't, then you have to start trying to break it down. Now, negative 32, there is a 5th root, so I don't need to do anything to that number. What do I need to do to the x, though? Because 7 is not divisible by 5. How do I rewrite that? Take out 2. So it's going to become x to the 5th, and then x squared. And then I don't need to do that to the y, though, because 10 is divisible by 5. Okay, what is the 5th root of negative 32? Good, negative 2. So this becomes a negative 2. X to the 5th is just going to become x. I can't do anything to x squared. Y to the 10th is going to become y squared. So the only thing that was left was that x squared. That has to stay underneath the 5th root sign. All right, so 16 and 17 are along the same lines. What I'm going to do is I'm just going to write down what the answer should be, and if you guys want to try them on your own at some point, you can. So 16, you should end up with, oops, this is your answer. And 17 should be that. Okay, so if you want to give those a try and see if you can figure it out, you will have letters that come out with the letters that are already in the front. Remember, when you guys multiply letters, you're adding the exponents. So when you have like x to the 5th and then x to the 3rd, you add 5 plus 3. It's the reverse of what we were doing throughout this lesson, where we were splitting it apart. You're putting it together, so you do that by adding.